Okay, today we're going to look at the hyperbola. So, quick review of standard form of any conic section. Remember that typically b is going to be equal to 0, so that term won't be there. And now if we do b squared minus 4ac, if that comes out to be bigger than 0, then we are going to have a hyperbola. When the b is missing, the easier way to think about a hyperbola is that the a and the c have different signs. So that's really the way that we can tell. Because we're not really going to have that xy term in there. This is the official way to tell, but far away a and c will have different signs. So notice it looks just like an ellipse, except the difference is one will be positive and one will be negative. And we almost always write the positive one first. So watch out for this. It could also be written this way. And the a and the b don't matter. We just know that the one under the y goes in the y direction, and we'll talk about when we do examples, you'll see what I mean. But notice that I could have the y first. That just means that the y is positive. So we like to always write the positive one first. So you'll notice that the x and the y can switch. So you have to be careful. You got to pay attention there. It's not always going to be the x one first. But it's the same form as the ellipse. It's just that one of these is positive and one is negative. That's why you'll be able to tell from up here. If the x squared is positive, then this y squared term must be negative, or vice versa. We always write the positive one first. So here's our definition of a hyperbola. So first of all, there's lots of stuff on this graph, but I just want to trace. This is the hyperbola, just this. These are called the branches, okay? The two parts I traced in purple, that's the graph. All the other stuff is just an aid to help you graph. And we're even going to throw some asymptotes on there as well to help us. So this is the graph of a hyperbola. It's different from, it's similar to the ellipse, but the difference is the distance is back to the foci. It's now when we subtract them. So if I have a point on the ellipse, like on the hyperbola, like let's say right here, this distance here back to one focus, I'll say the purple, and the blue, the distance back here to that. If I subtract one from the other, whatever number I get, I'm going to get the same number again and again. So no matter what point I'm on the hyperbola, I'll always have the same number. Even though the blue and the purple distance change, when I subtract them, they're always equal to the same constant. Whereas in the ellipse, it was if I added them together, they're always equal to the same constant. So it's a similar definition, but different in that the addition becomes subtraction. Some other parts here. We're going to call on each branch, they have their own vertex. So I'll kind of highlight that one. Well, they did the foci in blue, so I'm going to erase some of the stuff I wrote here. The vertices, there's one on each branch. You can kind of think of it like the vertex of a parabola. So those are the vertices there. And we'll be able to find those in relation to the center. We'll see when we do an example here. And then there's the foci in blue. So we'll be able to find that distance from the center out to the foci as well. Okay, so we're going to want to know the location of those foci. And those are in blue here. And they're not actually on the hyperbola. All right, so we've already discussed. Here's the graphing form of the hyperbola. A and B is the distance from the center to the vertices. It's A or B depending on the orientation of the transverse axis. So again, we'll talk about how we decide. The branches can go like how they are now, where the transverse axis is horizontal, or it could be vertical, and then the branches would look like this. Okay, and so we'll talk about when we know which one's which. Remember, we have this equation that's stemming from, it's a little bit different than the one for an ellipse. It's stemming from Pythagorean theorem. Again, I can show you where it comes from if any of you are interested in this. But this distance is the distance from the center out to the foci. And so then the a squared and the b squared are these guys here. And they're gonna, I'll show you again when we do an example. We'll see the picture, what those represent on the picture. And so we can solve for c by square rooting both sides. So again, I think of it as Pythagorean theorem. You could just memorize this equation. Doesn't matter. Oh, I was already doing one here. So let's go ahead and do these examples. So they want us to graph each hyperbola and give the location of its foci. Go to purple. All right. So we're going to start with finding the a and the b. So that's a squared. So that means a equals 2. That's b squared. So that means that b equals 3. Let me be consistent here. B squared equals 9. So b equals 3. I know the center for this one is at 0, 0. So I should have pulled graph paper in for this one. These can get a little messy. I'll try to be very careful with my spacing here. You should do the same. So our center is at 0, 0. I'm going to try to make sure I'm really keeping my increments pretty accurate. I didn't do a great job on that one. Oops. Three, 4, 5. 3, 4, 5. 5. 1, 2, 3, 4, 5. All right, so our center is at 0, 0. Now the a means that it's underneath the x, right? So that means we're going to go out from the center in the x direction 2 units. And I'm just going to put like a small little dot there. Or what I'm going to do is go like this. I'm going to put a dotted line. Okay. And then the b goes 3 units in the y direction because it's under the y. So I'm going to put a dotted line there. And what we end up doing is we make this box. And we're going to use asymptotes to help us graph as well. So that we're going to draw these 2 lines that cross, these 2 dashed lines. They're not part of the graph. They're just asymptotes. And so those dashed lines go like this. And that is our asymptote. And I know this equation is, and they're always going to go through the center and the corners of the box. So I know the equation is y equals, this slope is rise over run, which is really my b over my a in this case. So it's 3 over 2x. And since it goes through the center, there's no y-intercept. Or the y-intercept is 0, I should say. And then here's my other one. And that's going to be y equals negative 3 over 2x. We don't need these equations in this example, but we're going to, like some questions I'll ask for the equations of the asymptotes or whatever, okay? Now the question is, which way do the branches go? So I can put my vertex down, my vertices down. So the branches always go in the orientation of the positive guys. So since the x squared is the positive one and the y squared is the negative one, these are going to go in the x direction, or the branches are going to go horizontally. That transverse axis, maybe I'll put that in green here. That transverse axis is going horizontally. So that means now when I want to graph this thing, this is actually the graph of the hyperbola. I put the vertices right there on the edge of the box because my a was 2. And then the branches go off in each direction. So these ones, this is kind of a wide, sweeping curve. It approaches the asymptotes, but never touches them. All right, so there's our graph. It's that purple solid graph. And now we want the location of the foci. So the foci, we know they're going to be, I'll put them here in green. We know they're going to be somewhere like in here or something like that, right? Because that's kind of where they go, kind of like inside the curvature. So let's find exactly where they're located. So I know a squared plus b squared equals foci squared distance. So I've got, do it this way, just so I know what we're doing. So our a squared is 4, our b squared is 9, so our c squared is going to be 13. So c is going to be the square root of 13, or about, let me do that on my calculator, it's about 3.606. So when I go graph these, I'm going that distance out from the center, so it's like 3.5-ish. So we'll just say it's like right about there and right about there, and I'll put the coordinates in and I'll use the exact value, square root of 13. So that's the square root of 13 is 0, and this is the negative square root of 13 is 0. There's my foci. All right, let's do the next one together. So again, the center is at 0, 0, because there's nothing in here with the y or the x. They're not shifted at all. So I have that center. I know that my a squared is equal to 16 and my b squared is equal to 4. So a is going to be 4 and b is going to be 2. Notice the direction they go in though. So it doesn't matter if I call it a or b. I don't get hung up with that. But notice the y squared is the positive one this time. So when I draw this, the transverse axis is going to go vertically now because the y squared was the positive term. So my branches will open up and down, not left and right. They'll go they'll open vertically. So in the y direction, my center's at 0, 0. I shouldn't, well, okay. It's not really on the graph, it's just a reference point. But my center's at 0, 0, and so I go up 4 in the y direction because this guy's 4. 1, 2, 3, 4. I kind of put my dotted line. And I know the vertex will be there because these are oriented vertically. 1, 2, 3, 4. Then I go 2 in the other direction. So here's my box. So I can draw my asymptotes. The equations, again, the center is at 0, 0. So the equation this one will be, the slope here, rise over run, is 4 over 2. So the slope would be 2x, and this one would be negative 2x. Or I should say the slope is negative 2. My orientation is they open up or down. So now I can sketch this graph. They just kind of approach the asymptotes and make this curvature thing going on here. I could label everything. The center is 0, 0. The vertices here are 0, 4, 0, negative 4. They want the foci. We'll do those in green. So it's going to be 16, not squared, it's already squared. 16, a squared plus b squared equals c squared. So c is root 20. So root 20 is going to be in between 4 and 5, kind of right in the middle-ish, I'll say. So about, let's just call it about 4.5 when I graph it. I don't have to be that accurate when it's root 20. So 1, 2, 3, 4.5 ski right there. Same thing down here. If I write in their coordinates, it's going to be 0. And then I can simplify it, 2 root 5, right? Because it simplifies to 4 times 5, so 2 root 5. And this one would be 0, negative 2 root 5. All right, so you're going to pause the video here now and see if you can graph these two. Okay, welcome back. So this is what you should have gotten for the first one. Okay, it should look like that. You've got your asymptotes in blue. I graphed them. And they go, their equations are 1/2 x and negative 1/2 x. For your second parabola, when we switch the x and the y thing, Oh, whoops. Okay, sorry. You'll get that, the purple graph. And actually you have the same asymptotes here. It's just the orientation switches and you get a different branches. You can see that you have your vertex here of your branches are negative 2, 0, and 2, 0. And for this one, I should have showed you that. These are 0, 1, and 0, negative 1. Let's come back to our notes. So that's what you should have gotten for those. Oh, foci, I should have given you the answers to the foci. Those would be the locations of your foci. All right, so now we're going to look at a couple. We'll do two where we're not centered at 0, 0. So we're going to start with our center being 2, 1. Oh wait, I have that backwards. Sorry, it should be 1, 2. I just fell for what I said. Watch out for. We like to put the positive one first, so I'm supposed to notice that that's the Y, not the X. So our center is at 1, 2. I'll do this in purple. Stay consistent. 1, 1, 2. There's the center, just a point of reference. Because the Y is positive, I know that transverse axis is going to go vertical, which means my vertices are on that thing. I don't want to put that on there, actually. It'll have too much going on the graph. Okay, so from here we go 4 in the Y direction. So we go up to 6. I got my vertex there. And I'm going to start making the box. Go down 4 in the Y direction, so I go down to negative 2. Got my vertex there. Got the start of my box. I go 3 in the X direction. So 1, 2, 3 over there. We got our box. And then 1, 2, 3 in that direction. So our rise here is 4 and our run is 3. So when I draw these in, our asymptotes, we can come up with the equations. They pass through the center. I know the slope is 4/3, and then I know the center point here is at 1, 2. So I'm going to write them in point slope form. We don't really need the equations when graphing, but I like to review it. So it's going to be y minus the y value equals the slope, which we said was 4/3, x minus the x value, so x minus 1. And this one will be the same, y minus 2 equals, but I'll have negative 4/3 for slope. All right, because we went out 3 to the right and then up 4, so our slope is 4/3. Here's our vertices. We can now sketch the graph. We know the branches go in this direction because the Y is positive, so we know they're going to open vertically. And then we just need the location of the foci. So 16 and 9 is 25. So C is 5. So now if I go 5 units up from here, the foci is like right there. And its coordinates are 1. And then I go 5 up from the center, so that would be 7. And then I would go 1 unit down here, and that would be 1. And I go 5 units down from the center, so it would be negative 3. There's my foci. Here's a look at it in decimals with I've got my equations, my asymptotes graph there as well. Oh, I should have labeled my vertices, yeah, on this one. So the vertices here are 1, 6. And this one here is 1, negative 2. All right, last one. We can tell this one is a hyperbola because the x squared and the y squared have different signs. So I'm going to complete this square like before. So minus 18x, and then leave some space. Minus 16y squared plus 32y, leave some space, equals 151. First I can factor out the 9. Minus 16, pull that out, y squared minus, because the negative gets pulled out, that's going to be 2y, yep, leave some space, equals 151. So I'm going to complete the square here, so x squared minus 2x plus 1, so I really added 9. I'll do that in the next step. Minus 16 times y squared, it's going to be plus, plus 1. I'm not factoring yet. Minus 2y plus 1. And here I subtracted 16. So now I can start factoring. I get 9 times x minus 1 squared minus 16 times y minus 1 squared equals 151 plus 9 is 160, minus 16 is 150, 144. So now if I divide everything by 144 so that I have my hyperbola equal to 1, let's see what we get here. So 9 into 144, it does not go in evenly, so maybe I can just reduce from here. So yeah, it goes in 16 times. So this will be x minus 1 squared over 16 minus 144. 16 goes in 9 times then, right? So y minus 1 squared over 9 equals 1. So we got our hyperbola here because we've got subtraction. Our center is at 1, 1, so let's get this graph done. If I go over 1 and up 1, there's my center. From there I go in the x direction 4 units. Oh, but because the x, by the way, is the positive, I know that my transversal axis will go horizontally. The branches will open to the right and to the left. So I'm going 4 out because the square is 16. So I'm going 1, 2, 3, 4 over. There's my vertex. 1, 2, 3, 4 over that way. There's that vertex. If I start drawing the box, we go 3 up and 3 down. So now we have our box. We'll draw in our asymptotes for help and graphing. And then our hyperbola looks like that. All right, we label some points here. Our center is at 1, 1. Our vertex is at, well, it's going to have a y value of 1, and then it's 1, 2, 3, 4, 5. So it's going to be 5, 1. And then we've got 1, 2, negative 3, 1. I'll leave you to find the foci. We can talk about that to start class if you have a question about it. All right, thanks for watching. Ooh, we did under a half hour. Nice.